In this video, we will use factorial and double factorial to generate the Taylor-Maclaurin series sum of the sine function. We begin with the sine function, which is equal to array formula, sine of the x values from 0 to 8. And we'll chart this. Insert chart. And we use scatter chart. Use row 1 as header. Customize in the series, show the trend line. The type, polynomial. The degree, 8. For the legend, for the label, use the equation. And the legend, position at the bottom. Here's the trend line and polynomial of sine. So next we calculate the expansion. So the Taylor-Maclaurin series sum expansion of sine, where is equal to the summation of a times x to the power 2n plus 1. And the value of n is from 0 to infinity. Can go as far as 16. 16 is good enough. And we continue with the value of a, because a can be factorial or double factorial. Start with the factorial. So array formula, minus 1 raised to the power n divided by, that is factorial, 2 times n plus 1. And we continue with the double factorial. Array formula, minus 1 raised to the power n divided by, this time there are two parts, double factorial 2n and double factorial 2n plus 1. So start with the first part. Double factorial 2 times n. That's the first part. The second part, again, double factorial 2n plus 1. So 2 times n plus 1. So their values are exactly the same. We now continue with the expansion, which is array formula, series sum of the x values raised to the power 2n plus 1, where 2n plus 1 starts from at n equals 0, 2 times 0, 0 plus 1, 1. So it starts from 1. Incremented by, next will be 2 times 1, 2 plus 1, 3. And after that, 2 times 2 plus 1, 5. 2 times 2 plus 1, 4 plus 1, 5. So 1, 3, 5, 7, 9. The interval is 2. And the coefficient. The coefficient can be double factorial or factorial. So we start with double factorial. And enter. We don't have the polynomial for the expansion, so we edit the chart. Edit, chart, customize, show the trend line, the type, polynomial, the degree, 8. For the label, use the equation. So now we have the polynomials and trend line for both. The function sine and its expansion in red. Next, we calculate the polynomial regression coefficient using LINEST. To do that, we complete the LINEST matrix, starting with the power. That's 0 to 8. So transpose 0 to 8. And the elements of the matrix. So array formula, of the x values raised to the power 0 to 8. Now we can use LINEST. So LINEST data y and data x. You can also use LINEST here. Data y, comma, data x. And we compare our polynomial regression coefficients with the chart, starting with x to the 0. 0. This is 0. 1.16 times 10 to the minus 9. Coefficient of x, 1.07. Coefficient of x squared, minus 0.194. Coefficient of x cubed, 0.0433. Coefficient of x to the fourth, minus 0.119. Coefficient of x to the fifth, 0.0474. Coefficient of x to the sixth, minus 7.38 times 10 to the minus 3. Coefficient of x to the seventh, that's 5.14 times 10 to the minus 4. Coefficient of x to the 8, minus 1.34 times 10 to the minus 5. That's because we're using the double factorial, which is this. We're using the double factorial. Suppose we use the factorial. Let's use the factorial. And enter. The values, the polynomial regression coefficients are still the same. The polynomials are still the same. The trend line is still the same. And the data sets, they're still the same. This completes the use of double factorial and factorial to generate a Taylor Maclaurin Series sum expansion of sine and its LINEST polynomial regression.